Okay, here we want to find the values of a and b that make f continuous everywhere. We have the piecewise function f of x, which is equal to x squared minus 4 over x minus 2 if x is less than 2. F of x is equal to ax squared minus bx plus 3 if x is in between 2 and 3. And f of x is equal to 2x minus a plus b if x is greater than or equal to 3. So we can see here that we have these restrictions, and the first one has a restriction from x is less than 2. So let's first take a look at when x is equal to 2 and then take a look at the limits. So for the first one, we have x is approaching 2 from the left because we are looking at this function here. So this represents from the left, so we know that this is x is approaching 2 from the left of that function. And the function that we're going to use, therefore, is x squared minus 4 over x minus 2. Okay, so now we can do is we can then go a little further here by simplifying. So x, the limit as x approaches 2 from the left, we can then factor this, the difference of squares, x plus 2 times x minus 2 over x minus 2. And we can simplify that to get the limit as x approaches 2 from the left of x plus 2. So now when we apply the limit as x approaches 2, we get 2 plus 2, which is equal to 4. So now what we need to do is we need to find the limit as x approaches 2 from the right. Okay, so when x approaches 2 from the right, that is this, which means we need to use the function ax squared minus bx plus 3. So let's go ahead and do that. We have ax squared minus bx plus 3. And so evaluating the limit at 2, we have a times 2 squared minus b times 2 plus 3, which gives us 4a minus 2b plus 3. Now, let's go back and talk about the definition of a limit. We know that the definition of a limit tells us that when you're looking at x approaching a value from the left and x approaching a value from the right, that these have to equal each other. So let's set these two equal to each other. So we have 4a minus 2b plus 3, and that's equal to 4. And therefore, we're going to leave this as 4a minus 2b, subtracting 3 to both sides gives us 1. So therefore, this is our first system of equations. Okay, so now we want to find out what happens at x is equal to 3. Okay, so we know that we want to find the limit as x approaches 3 from the left. So when we want to look at that up here, we can see that x minus 3 represents x approaching 3 from the left, which means we need to use this function right here. So we're using the function ax squared minus bx plus 3. And now let's evaluate that limit at 3. So we have a times 3 squared minus b times 3 plus 3, which gives us 9a minus 3b plus 3. Okay, and so now we need to find the limit as x approaches 3 from the right. So that's when we look at here where x is greater than 3. So that tells us we need to use this function here. So we're going to use the function 2x minus a plus b and evaluate it at the number 3. So we have 2 times 3 minus a plus b. And let's write it in the same ascending order that we have from the previous step. So we have negative a plus b plus 6. Okay, now again, going back to what we stated before, we're going to see that these limits from the left and the right have to equal each other. So we're going to set them equal to each other, and we're going to get 9a minus 3b plus 3, which is equal to negative a plus b plus 6. So now what we're going to do is we're going to add a to both sides. We're going to subtract b to both sides. And then we're going to subtract 3 to the right side. So we end up getting 10a minus 4b, which is equal to 3. So therefore, there is our second equation for our systems of equations. So now what we're going to do is we're going to solve now for a and b using these two equations as a systems of equation. So in step number 3, we have our first equation, which is 4a minus 2b, which is equal to 1. Our second equation is 10a minus 4b, which is equal to 3. So we can eliminate b by multiplying the first equation by negative 2 and leaving the second one the same. So we have negative 8a plus 4b equals negative 2. And then we have 10a minus 4b, which is equal to 3. So we can eliminate the 4b's, and we end up with 2a, which is equal to 1. So therefore, we can say that a is going to equal 1/2. Okay, now we can plug in 1/2 into equation number 1 or number 2. So we have 4 times 1/2 minus 2b, which is equal to 1. So half of 4 is 2. Subtract 2 to both sides, we get negative 2b, which is equal to negative 1. And therefore b is going to equal 1/2. And so for the function f to be continuous on the interval from negative infinity to positive infinity, we would have to let a equal b, which is equal to 1/2. So let's see what that would look like. So this is what our function was. So now we can write this as the following: f of x not f of x, we can write this as, the first function is x squared minus 4 over x minus 2 if x is less than 2. We know that a now is 1/2, so that's 1/2 x squared minus 1/2 x plus 3 if x is in between 2 and 3. And then we know that 2x minus 1/2 plus 1/2. Well, we know that that's going to give us 0. So it's just 2x. And therefore, if x is greater than or equal to 3.